Okay, hello, everybody. My name is Osherove. I started in the software industry about 20 years ago. I worked in a lot of different languages. I did a lot of different roles. I worked in very, very small startups and very, very large companies. I wrote a book called The Art of Unit Testing. It did great. I did a lot of talks about unit testing and test-driven development. For 10 years, I did talks about that stuff. And what kept frustrating me is that the questions always remained at the same level. That is, nobody ever asked the more advanced questions. Everyone seems to be repeating on neutral the basics. People have been trying to adopt unit testing and automated testing for years, sometimes, almost always, unsuccessfully, especially in large organizations. So I started looking into why that is, because also as someone who also became a technical leader, at some point a director, manager of various people, I also believed in these things that I thought were the right things to do. Unit testing and a lot of engineering practices and refactoring. But there was a huge difference between having those things in my head and actually getting the people in the field to actually do those things. Especially, the most frustrating thing is that I would teach people about these things, and people say, yeah, absolutely. And I would ask, okay, so shall we do it? And people said, yeah, okay, we're definitely going to try. And then nothing changed. Everything continued just as it did the day before. Everyone tried for 10 minutes before reality set in and moved them right back into where they started. So that's where I wrote a book called Elastic Leadership, which is all about how do you get out of that zone, which we call survival mode. How do you get out of that zone where you have no time to learn new skills and actually develop skills that will help prevent the fires and actually make time to learn and adapt to new ways of working? And I'm currently working on a third book already for like 2 years. To me, this stuff combines the two things from above. Enterprise DevOps really is the combination of applying engineering practices and pipelines to an organization and its processes, but it has to combine people and leadership in there with a dash of salt of various patterns that are specifically about DevOps. So the agenda for today, before we talk about the tips and tricks that to me help make something successful in these large transformations, we're going to talk about influence. Because when we say DevOps, it's a completely different beast than when we say enterprise DevOps. So this is how I like to define enterprise DevOps. You want to apply DevOps values in an environment that has any of the following: many interdependencies, monolithic systems, lengthy approval gates, security, financial, medical compliance, waterfall-based processes, sometimes multiple of those, and manual and error-prone workflows. If that describes at least part of what you're facing on a day-to-day, then having DevOps at that scale presents completely different challenges than teaching a single team to take care of their own destiny, as I like to say. Because there are many levels. There's a person level that we want to be able to change. There's a team level. There's multiple teams. There's multiple disciplines that have to work with each other. There's multiple systems that have multiple disciplines inside them and multiple business units. And in one of the most challenging organizations I got to work with was an organization, a huge organization, that actually bought 4 companies that then had to work together on the same product in 4 different locations, 4 different systems, 4 different networks, physical networks, and they had to collaborate to build a product that was built of both software and hardware. It took them, they would run what we would call then a nightly build once every 3 months. They would send each other by email binaries to integrate against. They had completely different systems, network, anything. It took a year to move into an area where they had a fully integrated build with tests and simulators running every day. It took a year. And part of that year was about physically connecting the networks, like literally getting the company to drill new cables and connect the companies into the same network. But that was just a small part of that story. Before we get into the software business, I want to take a lesson from a completely different set of issues. If you've ever heard of the Guinea worm, has anyone ever heard of this before? This is a horrible, horrible parasite that used to be very, very rampant in Asia and Africa. It basically, you can get infected by drinking infected waters that have fleas that carry the larva of that worm. And the worm basically lives inside your body. And after about a year, with no symptoms, the worm lays eggs and then tries to exit the body through various areas in the body, usually through the legs. And it's a painful, horrible process that can take weeks or months. So it can be multiple meters of length, this worm that lives inside the body, this parasite. So the reason I say this is not because I want to compare enterprise software to that, but because when we talk about huge challenges, I want to give us a bit of context. What is a huge challenge? So in 1986, there were 3.5 million cases reported of that. And one of the doctors that was exploring how to prevent this phenomenon was called Dr. Donald Hopkins. And Dr. Hopkins basically tried to assess what is the root cause, what is one of the root causes that's leading to this kind of epidemic that is growing. And the root cause is drinking water not being filtered. So that's a vital behavior that he wanted to change. People were drinking contaminated water, and he wanted them to start drinking filtered water. Okay? That's a single behavior to change in millions of people across multiple tribes, multiple regions. So when he tried to attack this problem, he encountered various issues. The first issue is personal motivation for people to do this. The most obvious personal motivation for people to not do what he asked them to do was pain. You see, when that worm is trying to get out of your body, I'm going to spare you the actual pictures of what it looks like, but this is a stick where people actually have to get the worm out and they have to wrap it around the stick over weeks and months as it slowly exits the body, okay? This process, hugely painful. One of the only ways to actually alleviate the pain is to soak your foot in nice cold water, which basically meant that if we want people to stop contaminating the water, we want to ask them to continue the pain. We want to ask them to stop soaking their feet in water so that they can stop contaminating the water so people can actually have more safe to drink water. So their personal motivation was actually going against what he was trying to get them to do, which is stay away from the water. When a person is infected with that, they can, as long as if they touch even a few drops of water and that water is contaminated, it doesn't matter how big the source of water that's clean, it will already be risky. So that personal motivation was very difficult to handle. But that wasn't the only thing. The second thing that he encountered is the personal ability of people. Well, he wanted people to start filtering water. So what you can see here on the right is what he wanted people to do. Any water that they would like to drink, they have to go through special filters. But people were making mistakes. While they were actually filtering, they were splashing things over, they were spilling dirty water into clean water, and they basically made a lot of mistakes which nullified their attempts. So instead of solving the problem, it actually just got bigger because people were splashing what they thought was clean water, and they're using it, but they were actually infected. The third thing that he encountered is trust. He wanted to teach people how to use tools and how to actually avoid these things. But when we're talking about tribes, they needed to trust him to actually listen to him. He came in as an outsider. The chief listen to him in a specific tribe. But in a specific village that we're talking about for this experiment, where it started, there were 2 other tribes that did not trust the chief. So just because, specifically because he listened to the chief, they did not trust him. And the chief was kind of considered to be not truthful. There were other opinion makers that he had to actually go through to convince people to even listen to what he has to say. And even though he did all these things, he still needed support. Support is where people have to band together and do things not alone. Social ability is strength in numbers. If I'm trying something alone, and I'm the only one trying it, it's going to be very, very difficult to keep doing it if I don't feel like there are other people that feel my pain, that feel what I'm going through. And in that specific village, there were also physical aspects to it. When people were sick, they were not allowed to go near water, so someone had to bring water to them. So the whole village had to help people and bring them clean water, because it was very, very tempting for those people to just go to the water source themselves. So they had to give them a different option. And they also had to band together and band their tools together so they can bring more water and filter more water at the same time. In other words, if they tried to do it one by one, it would have been impossible. Now, structural motivation. Add to that money. Those people were living hand to mouth, which basically means that they were using their job every day, usually near the water sources, to actually make money. If they didn't have the job, they didn't make money, they wouldn't actually have food to eat. So they had financial reasons to go near bodies of water and actually do work there, because otherwise their family would starve. And lastly, structural ability. They needed the physical ability to do the filtering. They needed the tooling, they needed the wood. What you see here is an example of a pipe filter, which is a tool that was developed for the purpose of being able to drink from water sources for a single person. What you see there is a filter for a full family. So developing these things, having not only teaching people, but having those things available so people can use them, was a big part of it. So when we try to equate this into the software world, we can usually see a lot of equivalences for trying to change people's behavior. Now, the book that I read that really changed a lot of the way I think about these things is called Influencer, The Power to Change Anything. And the story is written in that book. There's also a great video I'm going to explain to you in a second. I'm not going to show the video because we don't have a lot of time. But there were basically 6 factors that the book details that today I find are the key to actually understanding why things are failing, both in small and really large organizations, and being able to try to change them. And that is personal motivation and ability, which is where we all usually stop. If you've ever tried to get a person to do something in your organization, usually try 2 things. You try talking to them and explaining to them it's a good idea, and you maybe sent them on a course. A 2-day Scrum Master course, a 3-day TDD course with Roy Osherove. What could go wrong? That person wants to do unit testing. He went to a 3-day unit testing course. It's supposed to work now, right now, but we're stuck. Something doesn't work yet. And this is where the 4 other factors that we almost never consider come into play. The social motivation, social ability. That's the people around us, the people we trust, the people we follow, the people that we will listen to their advice. Because if I think that TDD is a great idea, but the person who's been mentoring me for years, that I fully trust, the architect in the team says, TDD is crap, it's going to be very likely that I'm actually not going to do it because the person I really respect thinks it's not a good idea. So to change my behavior, someone might need to find me another person that I really, really trust that thinks a different way from the other mentor. Maybe a different book or a different author or a different speaker, doesn't matter. But that's an example. Strength in numbers is also the social ability. If I'm doing something alone in a large organization, it's going to be very, very difficult mentally to try to do something. But if I know that there are other people struggling, it might give me some more strength. It's kind of like Alcoholics Anonymous, if you think about it. What is Alcoholics Anonymous in a way? It is a support group. It gives me strength in numbers, strength to know I'm not alone. I have someone to turn to when I need something to do. So imagine test-driven anonymous in an organization, like a small, quiet group, like a small meetup inside the organization, where a person that believes in the right thing, they meet once a month and they talk about all the crap that they have to go through in their own little sub-organizations. But they figure out things. They say, oh, you know what, if you do this, we can help each other. So that gives me strength to continue, even though the journey is very, very long. So with these four things, what happened is that in 1986, we had 3.5 million. In 2015, there were 22. Not million, just 22 cases reported. This is the type of change we're talking about. Now, if we can get this amount of people to change their behavior, I'm sure we can get 100,000 or 5,000 or 200 or 30 to move into new types of behaviors. And the video is over there, so when you get the slides, feel free to watch the video or just Google it or Bing it. It's up to you, really. These are the 6 influence factors. And the reason I'm including this is because from now on, whenever I talk about tips and tricks to succeeding with transformations in a big company, we're also going to talk about which factors of these are we actually touching. Why would that work? Okay? A key important thing to understand here is that it only takes one of these things to stop a behavior from happening. That is a good behavior. That is, if I want a person to do pair programming, if I wanted a person to use a pipeline, if I wanted a person to do a code review, it doesn't matter. If I wanted a person to merge faster into the master branch, it doesn't matter what the behavior is. It only takes one of these things to stop that person from doing that. And one of the sentences that I like in the book, I'll paraphrase, is that when you see a behavior in the wild of a person, then the world around that person is perfectly designed for that specific behavior to happen. In other words, if you were that person, if you had gone through everything they went through, if you had their house, their kids, if you had their dog, and if you had their manager and their work environment and their budget and anything, you would have done the exact same thing. And that's the point here. We're trying to look at the environments around people to try to change the behavior of an organization. So let's see where it usually starts. Big bang transformations are where usually a company, C-level executives will discuss this quote-unquote agile development thing and decide that they want to jump in. So they're going to do a transformation. They're going to hire a consulting firm that takes sometimes millions of dollars, and they're going to come in and say, and basically announce to the organization after 6 months, from now on, we are all going to transform into X, which X could be anything. In our case, it could be DevOps. So we are starting our transformation now. Our plan is to finish it in about 3 years. And from this moment on, we ask everyone to behave in a specific way, which is completely different than the way we asked you to do it before. And they bring in all the middle management, and they announce this ambitious plan. And middle management goes, okay, yeah. And when they ask them, do you have any doubts? Remember that usually the question is, do you have any doubts? Is after the plan has been formed, the budgets have been set, and a year has passed. Any doubts actually don't have any place right now. So middle management goes, absolutely, let's give it a try. And from that moment on, over the next 3 years, it starts. And people start doing the right thing. They say, okay, we want to be agile. Automated testing. Well, actually, there's this one thing we have to do. We don't have time to do it. Okay, but we want to deploy to production. Well, actually, compliance, but there's this issue. Okay, but we want to have we don't have the budget for this. And they come across all this stuff. Interdependencies and the approval gates and all that stuff. Because when we're trying to change the behavior organization, we have to look at these things in the context of the things there on the left. Where do these things fall? So this is usually what happens. Focus, fear, panic, abort. And then almost immediately, within a couple of months, things almost always come back to a more desirable, stable state, which is the state that was before. So one of the key things to make sure that we try not to do when we adopt these things in large organizations is not to do a big bang, but to always start with pilots, a set of pilots. Now, the thing about pilots, applications, and teams is that they provide two things. First of all, they allow a team to learn these new skills and abilities of working with a pipeline. You see, it's personal ability. People have to learn how to work in a DevOps organization. When you put these people in a separate team, you're also removing them from the constraints of regular teams. You're specifically deciding that for these people, you are changing the rules for. So for a pilot team, you might have different rules in the organization than for a regular team. And the point of a pilot team is that if you start there, let's see if this works. If you start here, this is the first pilot team. Here you can do 2 pilot teams, and then the people from these pilot teams will merge, will join other pilot teams, and then slowly, as the organization grows, as the pilot grows, the knowledge grows between people. So you have knowledge sharing. Now, what happens in the first one? In the first one, that's where all the pain happens, remember. But this time, the pain might be a bit more manageable, because when we try to do a pilot team in an organization, we actually have no idea what we're going to face in a large organization. We think we know what the result should be. We want to be able to deploy sometimes multiple times a day, small changes, small commits, full confidence, feedback loops that are fast, all that good stuff. Engineering practices, do all the right stuff. We know kind of what it's supposed to maybe feel like. We have no idea what it's like to take this. Let's imagine that we have a ball in our hand, and the ball represents a single requirement. Okay, I'll use a story. We have no idea, usually, in a big organization, what it takes to take this ball from this side all the way to that side of the room, if that side of the room represents deployment in production, running on a customer machine. We have no idea what's in the middle. We think we know usually this part. Maybe we don't even know this part, which is the definition of the requirements and all that stuff. And maybe we are usually there somewhere in the dev part. And in large organizations, you have a bunch of verification, especially in pharmaceutical stuff. And then here you have finish line, and then you have another set of teams. And all these people don't usually talk to each other. So when I was doing large-scale consulting for companies, we mapped out, by actually trying to map out the process, how many people are involved in delivering a feature all the way to production. And in one of our organizations, it was over 120 people. Okay? I'm talking about a single user story. How many people does that story touch across the organization? Because there were people from compliance, project management, of course development, and testing, and automation, and what else was there? And deployment, and infrastructure, and security. Okay? What else was there? Environment, integrations, and of course there were all the committees in the middle. If you don't know what the committees are, those are sets of people that are managing change in the organization. Change committees. Has anyone ever encountered these? Change committees are basically the human equivalent of trying to create a decision pipeline. If we deploy that software before we deploy that software, is anything bad going to happen? We only have this amount of people to test this software before we deploy it, but they're already busy with that, so what's going to happen? So if they meet once every 2 weeks or once a month, that basically means that whatever we do is always stuck 2 weeks or a month before it even gets a decision to do something. And of course, let's add to that the fact that almost all the decision-making software is manual. And suddenly it's not a big surprise that it takes 6 months or a year or 2 years to deliver a feature. Like if you put a GoPro on the forehead of the feature and you said, okay, tell me everything that you go through. He said, okay, well, first of all, someone writes me. And then I sit there for like 3 months before someone reviews me in their decision-making metrics. And then I wait for another couple of months, and then someone decides if I have a budget. And then I wait for this, and et cetera, et cetera. And then you measure how long it takes. And that is, by the way, our cycle time. The cycle time is not our release frequency. We might release every 2 weeks, but the code that we release might be a year old. This is our cycle time. It's like looking at the light from a star and realizing that the star might already be dead. Okay? So application pilots are a great way to map all of these things, encounter them head-on, document them, and find a way around them in the organizational policies, compliance, everything, and fix them for that specific team as an exception in the organization. So basically, when we're able to do this in the way we would like, which is a fully automated pipeline, then on the way, we had discovered all of the barriers for a feature in this type of project, in this business unit, in this organization. And that is the thing that we pass on to the next pilots. Because now we know what the policies might be needed, we can apply them to the next teams and learn how to make them better. The next steps would be somewhere around here. We start to develop knowledge base, which basically means we've figured out what it's like to develop a web application with all the security needs and compliance for this organization, especially credit card related, etc. So these are all the requirements that you need. Here is a wiki that shows you what are the steps. Maybe here's a bunch of templates that already live up to those requests for this organization. This is where you start. This is where people can start onboarding themselves. So these pilots represent usually a piece of knowledge about a specific way of building a specific type of product. So web applications will have a different type of pipeline than other types of applications, like backend, for example, or credit card processing. Okay, so the end-to-end view is a lot of times this is where we fail the most. When we do the transformations and we don't do them full on the entire organization, we usually miss understanding what it is the thing that's actually stopping us from achieving a fast cycle time. So we're talking about structural motivation and ability. Structural motivation and ability, I'll remind you, structural motivation is the things, the reward systems in your organization to do the right thing or the wrong thing. I actually have, if I have 3 kids and I want them to eat something every once in a while, I have to pay for that something and the company pays me. If I do a behavior in the company that leads to me getting a bonus or not getting a bonus at the end of the year, guess which behavior I'm going to choose. It doesn't matter how much I believe it is the right behavior. It doesn't matter how much I think it is the wrong idea. At some point, someone's going to put food on the table, which is back to the financial reasons. So we want to develop, in a company, we want to develop a reward structure that pushes us into those right behaviors. Because and I've seen this before, I've seen developers afraid to refactor a 300-line function. So I sit there with the developer and I said, why don't you just take these 3 lines of code that you just added in the middle of this huge thing? Why don't you just put it in a separate function with a good name? I mean, what's the big deal? And he said, no. Please don't ask me to do this. Why is that person so afraid? And I said, why are you so afraid? He said, I'm not afraid, but if I do this, then that refactoring was not asked, and it would have to go through a separate code review. And the architects are not really available, so it would have to wait for about 3 days. And I would have to explain why I spent my time working on this refactoring instead of adding more functionality. Okay? So now that person is afraid to refactor. He wanted to refactor. He knew what is the right thing to do. But he had organizational reward systems that were completely screwed up. Because if his team lead came in and said, why are you refactoring? Immediately you've lost already. We want to ask now the team leader, why are you afraid for your team member to refactor, right? Because it's not the team leader's fault. Remember, everyone works, not in a vacuum, but in a system. So then the question then goes to two people, the team leader and the architect. I asked the architect, why do you only review things once every 3 days? He said, well, I don't have time. I'm fully 100% developing, and I'm also doing all the code reviews, and we have 300 developers, and we're only 2 architects. Interesting. So is that the architect's fault? No. We put them in a system that does not allow them to do the right thing, but allows them to do the wrong thing, which is also the easiest thing, which is just delay it. So in that system, we had to do 2 things. First of all, allow more people to do code reviews and reduce the time for the architects so they can teach other people to do that stuff, so that more people can do refactoring and do code reviews, so the code quality will actually change. This is the small stuff that changes the big stuff. Because if you don't think that this is the stuff that changes big companies, remember that whenever we want to deploy something, we need to have confidence that it works. And many companies achieve that confidence in different ways. But one of the most normal ways to achieve that confidence is testing, right? And testing can be manual, it can be automated. Usually it's manual in big companies, unfortunately. Why is testing manual in these big companies? Because it takes such a long time, right? We are so much wasting time in manually testing, we don't have time to write automated tests. We don't have time to write automated tests, we do more manual testing, which means our cycle time becomes longer and longer, which basically means the company is less competitive in the market. So if there's a small internet bank that can deliver much faster than I can because they have automated tests, what's the difference between an automated test and a manual test? There is a developer somewhere or a tester somewhere deciding to write a piece of code. It's just a decision. It's a small decision. Should I do it manually or just automate it because I seem to be doing the same thing? And then that manager's person going and saying, either saying, why are you automating this? You don't have time to do this, do it manually. Or, that's great, please do more of that. That's the difference. It's a very, very small difference. That difference now escalates in a huge company across hundreds of people that make the right decisions or the small decisions that are not right. And that kills organizations. So when we look at the end-to-end holistic view, I'm going to return back to this for a second. We have to, first of all, understand where is the bottleneck in the organization. Whenever I come into a new company, the first thing that I do is I ask people, do you know what does it take for a story to get from one side of the room to the other? Do you know? And usually people don't know. They know parts of it. Every person sees a part of the elephant. If you've ever heard the elephant story, there's an elephant, there are blind people, each touching a different part of the elephant, and each one thinks an elephant looks completely differently. But it's the same elephant, sorry. So, we need to understand the whole elephant, which might take us maybe a couple of weeks to understand. Sometimes it's about getting all the stakeholders in a room for a few hours and documenting what does a user story or a feature go through in our organization. And once we do that, we ask 2 questions. How long does it take to physically do the actual task, for example, testing a single feature, versus how long of a waiting between things. So if I write a requirement and it takes me 30 minutes, but then that requirement sits there until the next requirement planning for 2 weeks, then the total time will be 2 weeks, but the actual time will be 30 minutes. Okay? Now, why is that important? Because for each of these things, we want to see where the bottlenecks are. The bottlenecks can be either things that are waiting to be done or things that are just taking a long time because they're error-prone, they're manual. For example, testing could be an example of that. And then we measure and we look at the entire process and we look for the biggest things. And sometimes those big things are not in the development space at all. Sometimes they're in the requirement space, sometimes they're in the verification, sometimes they're in the infrastructure. There is a huge variation between organizations. But the thing is, what we want to avoid is optimizing the wrong thing. A lot of times when people think about DevOps, they think about code and maybe infrastructure. But when I think about DevOps, I think about organizational pipelines. Because security should also be in that pipeline, and compliance should also be in that pipeline. And if it's manual today, I'll have to find a way to automate those checks in some way, at least as much as I can. So it's a cross-cutting concern across the organization, but which one should I work on first? Which one should I focus on? And you might see that development sometimes is negligible, when in fact you could do huge changes just in the cycle time of the entire organization, just by changing things before or after, or by giving people different permissions to do things they didn't have before. So what we want to look for is two things. We want to look at the overall time, and we want to look at how much time waiting there is. So if it takes me 3,500 hours to deliver a single feature, but the actual working time is 500 hours, it means that from a project percentage, for every dollar that I spend, I get 15 cents back. Okay, I have to spend $1 to get 15 cents. Because there's a huge waste in the system. So I'll usually do something like this. This is something I actually do with organizations. So I'll sit there, we'll have a big Excel file, and we'll start documenting. So at the top, what you can see is, these change all the time. These are all the handoffs between various groups, okay? Here we have total number of days, total number of weeks, total number of months, and then here we have the tasks. So when something starts at product management, it goes through this task, like let's say wait in queue for a day and a half, review request takes 2 days, okay? And then it moves to the PMO, waiting queue, supplier assignment, et cetera, et cetera, et cetera. So it always goes down and then to the right, down and then to the right. And what we usually end up with, if we try to map this, is we look at the average cycle time for a specific feature. In this case, it's 11 months. And when we have this meeting, usually the questions are, on average, what does it usually take? Because features can be small, they can be big, but we're talking about on average for this specific type of application. It's very, very important to realize that we're looking for averages here, because on average, we want to reduce the average cycle time. There are always extremes to the left and to the right, but on average, we want to be faster. So that's an example of looking at the big picture and understanding where the bottlenecks actually are. The second thing that we have to realize that we need to do is that we have to look at the policies in the organization if we want DevOps to actually succeed. Okay, this is an example of pipeline. It's actually two parallel pipelines. We have a development pipeline at the top where people commit and they build the application and validate the source code and they deploy the application. And on the bottom, we have ephemeral environments, temporary environments. The environment is defined in code. It gets validated every time that environment changes. It gets deployed, and the application gets deployed into that temporary infrastructure. So these are like two pipelines that get merged into a single pipeline that runs acceptance tests and capacity. So this is just an example, imagine like a perfect world pipeline. But this pipeline is missing a key thing, which is policy. Because if I took this pipeline and I gave it to almost any team in a large organization, they're going to say, yeah, we agree, but we can only do the first part. Because acceptance tests are done in an environment we don't have access to, we don't have permission, we don't have the resources, or other people are in charge of capacity, and our compliance does not allow us to do production deployment. And to do that, we have to get either lawyers involved or people have to check boxes, and that's a whole manual process. So the policy has to be part of the transformation. So whenever we look at manual stuff, quality gates, performance, architecture, compliance, security, any type of that stuff, the first thing we need to consider for the pilot team that we started with, what is an exception in the organizational policy that allows that team to do their job? If the team goes and says, we try to deploy, but that person says we're not allowed. Okay, quick huddle. Who says you're not allowed? Well, this person. Okay, let's go and talk to that person. Why are they not allowed? Well, that's the policy. Perfect. Who sets the policy in the organizations? In any organization, especially when we're talking about compliance related, there are people that set the policy. And usually the people that set the policy are people that are very, very detached from the development lifecycle. But they care a lot about the business lifecycle. So usually we're not involving them, but this is the right time to set up a policy committee, and we call them tiger teams. First of all, because the word tiger is really cool. I would like to be in a tiger team. If someone said, do you want to be in a policy exception team? I'm not sure. But a tiger team, that I might be able to do. And the point of a tiger team is to develop a temporary exception policy in that organization just for that single team to be able to go all the way to production. Now, it might take months to develop that because as the team tries to do something and they don't get permission because they have to do something manually, that the committee comes into play and says, okay, under which conditions can we create either a script that replaces that manual check, that if the script says it's okay, we're okay. And a lot of times what you'll see, especially in the security world, is that the people who do those things already have their own scripts. They're just not integrated into the pipelines. In the compliance world, it's a bit more difficult because a lot of times it's going over systems and going over documents, making sure the documents exist in the right locations, making sure that things were documented. But a lot of times it's actually easy to automate those things because they might be one-offs for each organization, but they're not complicated one-offs. They're usually go and check that specific thing exists, go and check that specific line exists, go and check that people have done X, Y, Z, which you can usually get from a pipeline automatically. For example, did all the automation tests pass with at least 98% success? Check. We already know those scores. It's all a matter of connecting the dots. So as the team progresses in their pilot, they come across a specific problem, and the Tiger team helps them overcome that problem and create another addendum into this temporary policy. And after the first pilot team finishes, we have a temporary template for a policy for a specific type of product. And now we take this policy and we try to apply it to another team and say, given this policy, are we able to do your job? That's a second pilot. And if that policy is good enough, we try it with maybe a couple of other teams, but this time different platforms or technologies. And we see where the variations are. So sometimes after a year, maybe, sometimes after 6 months, you might end up with at least some pieces of knowledge where you have teams that have exceptions in the organization that can do continuous delivery. Once you have that in a specific amount, which any organization defines differently, the organization can decide to change the default policy into the exception policy. This is not mine. Okay. I think my laptop disagrees with me. Let's see. Is he dead? Okay. Questions so far while my computer reboots? I thought I got rid of Windows. Questions so far while the screen is red? Well, a lot of times what you'll see is that you have a checklist that you have to go through. And the checklist is documented and you know it well in advance. And so your policies will usually look at that checklist as a set of automated tests that you can basically go through and say, checked, checked, checked. And then what you basically bring in a lawyer in the company and you ask the lawyer, well, if this test checks this thing that a user personally looks at, is that good enough? And the lawyer might say, no. And then you ask, okay, under which conditions is it acceptable? And then the lawyer might tell you which conditions are. And then you basically negotiate a future where that stuff is actually possible. That make sense? Okay. Other questions? Yeah. Ideal? Okay. Yeah. Okay. Yeah. Yeah. Man, I have a slide for that. You don't see it, do you? Yeah, my computer is booting. But let me just answer that for a second, and then I'll actually show you the slide. What's your name, by the way? Hmm? Carloj? Carlos, okay. So Carlos is actually asking a very important question, is that how do you get the C-suite to agree to those changes? Is that correct? How do you get the high-level executives to even agree to this type of plan? Or the middle tier? Well, the nice thing about being a high-level manager is that they don't have you to usually agree. But what you want to make sure is that when you develop these things, let's see, I think it's back online. Let's see. Come on. When you develop these things, you want to make sure that you look at the organizational aspects, like in that chart that I showed you. Is that better? Okay. And in that chart that I showed you, if you look at these two things at on the right, on the green stuff, we're talking about what is a policy in the organization. It's structural ability and structural motivation. Basically, it means if I'm middle management and the policy says I'm not allowed to do something or that I'm required to do something, it means that now I have systematic push for a specific behavior. So if I can change the organizational policy to demand specific things from the way we work in this organization, that is basically our policy. That's, for example, if you go to your organization and the requirement is to always have a unit test for anything that you do. If you check it in without unit tests, it's not going to be approved. That's the policy in the organization. Uh, to to get people to do this, usually you don't have to do a lot. You just declare the new policy. If you get people that are not doing it, then the next question to ask is, which of these other things, the gray stuff, am I missing that's causing them not to want to do it? For example, for each person that doesn't want to do something, I'll ask a question. What is the personal motivation for that person for doing the opposite of that stuff? For example, in many organizations, I'm going to stop saying for example. In many organizations, people are pushed to doing the wrong behavior by their immediate managers, even though the top level managers are pushing for a completely different thing. And so then the question is, why do those immediate managers feel that that is the right thing to do? Sometimes it's a matter of sitting one-on-one with a person and understanding what are the things that react. And from that, you gain an understanding, what did you miss in the set of changes, okay? So policy is just an example, like a top-down change that represents today a wall. Even if everyone wants to do the right thing, they're not going to be able to do it. So we have to break that wall regardless of anything. Now, the question of whether they want to do it, I wrote a whole book about that stuff. It's called Elastic Leadership. And if you want, we can talk about like all the influence forces and all that stuff. Happy to talk about it. But maybe you're going to get another answer here. Here's another killer for anything that you want to change in your organization. If you want to get something, measure it. If you want to get the opposite, measure it. Measure the opposite. Metrics are the one thing that I see, other than policies, that prevent people or push them to do the right thing. Examples. How many people here measure coverage in their tests? Okay. Okay. Does anyone here have a minimum amount of coverage required? What's the minimum? 80%? 95? Anyone else? 93.7, what? 99? Okay. And here, okay. Now, in large organizations that might not raise their hands right now, giggle if you've ever seen people try to get coverage by writing really crappy tests. Okay, that's good. So I've actually been in those organizations where you can hear, The team lead comes in, middle manager, right? Okay, team, listen. Management is really pushing us to get high coverage. So this iteration, we're really going to push for getting really high coverage. What's going to happen at the end of that iteration? They're going to get high coverage. Are they going to increase their quality? Probably not. Because you're going to hear these conversations. Hey, I think I know a way to get high coverage. Write a loop in the test and just execute. Use reflection. Do whatever you need to do. 10% extra coverage in one day. I'm the hero of the organization. So coverage is one of those metrics that is meaningless. It is meaningless. 100% code coverage does not mean anything. But 10% code coverage means something. What does it mean? It means we're missing tests. That's all it means. But 100% code coverage is meaningless because I don't know what is the quality of the tests. So when we measure the wrong things, we get the wrong behavior. So I don't measure coverage. I might look at it, but I don't ask for accountability on coverage, if I can help it. And if I do ask for accountability because I consult for an organization that has already done this, I demand that coverage is always backed up by review of the test quality. Because 100% code coverage with code reviews that actually measure the quality of the tests, that's better. Sometimes you can also add mutation testing, which is basically a good way to test our tests. It's a way to change something in the code and see if a test fails. Nothing fails. We're either missing a test or the existing tests are actually bad. So coverage is one of those things. So what are good metrics? Lead time to change, which is our cycle time, that's a huge, great metric because this is the thing that allows us to be competitive in the landscape. And that stuff we can also measure at the team level. From the beginning where I get a request to deliver something until that something is delivered to a specific environment if I live in a big organization. I can measure my effectiveness in delivery or fixing or hotfix frequency. We can check our release frequency, defect rates, or other people call them escaped bugs. I want to measure my escaped bugs. Bugs found in production. That's a great metric because that is the thing, no matter how good my tests are, etc., escaped bugs test my pipeline. Escaped bugs are a measure of how good my automated pipeline is. And if it escaped that pipeline, it means I'm missing those tests. It means I'm missing those things that are so important to get confidence. Mean time to recovery is a great metric that I would recommend to replace if today in your organization you're testing mean time to failure. And I'll explain the difference. Mean time to failure checks how long between failures. So if you've ever heard the term 5 nines, or etc., that's the mean time between failures. That means how long can my application stay up without failing. Mean time to recovery, well, let me explain why this is usually the opposite of what you want. If I'm the operations person and I'm measured by mean time to failure, then my motivation is to make sure that the system never fails, right? What's the best way to make sure a system never fails? Never change it, right? Which means don't deploy. So my motivation, if it works, don't touch it, right? What are the developers' motivations? Change it. Change it and change it again. That's what we want. But our IT people say, over my dead body, are you going to change that stuff in production, sir? Never. Because one of their metrics says, every failure is your failure. That's basically what it means. So if I get less money at the end of the year because there are many failures, guess what? I'm going to fight you in deployment. So even though the policy might allow it, the metrics will push me toward the bad behavior. So what if I change it? What if I say, instead of measuring failures, I'm going to measure recoveries. From the moment of failure, how long does it take to recover a system in production? If I'm measured by that, what's my motivation now? Now, my motivation is no longer the failure, because the failure is not actually measured. I can measure it, but can look at it, but it's not accountability based. My recovery is accountability based. So if my manager comes to me and says, I noticed that our average mean time to recovery was 3 hours. What the hell's going on? What's my motivation now? My motivation is now to work with development on developing either faster deployments, getting a system that can automatically roll back its own changes, or even better, develop the idea of feature flags. So I can turn off features or roll back just a single feature. Or maybe create a system that during failures automatically has different deployment patterns that allow me resiliency during deployments. Right? So now our motivations are the same. And that's why metrics are that third key that really closes that thing. So when you look at a team that's supposed to be doing the right thing, and everyone around them wants them to do the right thing, and they're not, look at the metrics that they're using. Go to the meetings that team is having. Look at their PO meetings, look at their management, all their status meetings, and listen to the questions that people are asking them. Look at the charts that people are looking at on the screen. The charts are time-based. What KPIs is the organization looking at? And you'll notice that whatever the KPIs are, those people's behaviors is fully all about delivering those specific KPIs, even though if that contradicts everything we're trying to do. Okay? So metrics can be the deciding factor of where middle management is trying to do the right thing or not. Because metrics are also part of policy in the organization. So this is an example of that opposite of what I would expect. So when I come to an organization and I try to consult, a lot of times the team leads come in and say, okay, we're going to do DevOps. From now on, we're going to have automated builds, and they always have to be green. No. You've already failed. Now it's okay for a build to be red. In fact, if a build is always green, I'm actually kind of worried. Because if I tell you, again, if I'm saying a build has to be green, what am I telling my developers? We were in the IT world, now let's talk about developers. If I say you cannot break the build, because that's bad, right? It used to be, maybe you got a shirt for it, it'd be kind of funny, but really not. It's not funny. If you broke the build and that's bad, what am I now afraid to do? Merge. I'm afraid to merge to the master branch. What if I break the build? I don't want to be the idiot who broke the build. I don't want to feel bad about it. I don't want to hold up everyone else. So now, mean time to failure can also be considered at the development level. And when we talk about breaking the build, we're basically saying mean time between failures. What we, again, want to measure at the team level is not how many red builds we have, but how much time from red to green. That's what I want to measure. So time between red and green, if I say, okay, there were 3 red builds, so the time, on average, is 1 hour to fix a red build until it becomes green. What is the motivation of the team now? The motivation is, first of all, to do something when there's a red build. In a lot of teams, it's like, okay, there's a red build. I guess someone is going to do something about it at some point. But now the motivation is, let's do something about it because we're measured on it by how long does it take us to fix. Okay, we're not measured on the amount, we're just measured on how long it takes to fix. Because that's, again, where we want feature flags and rollbacks and all that good stuff that comes in with continuous delivery and integration. We want to be able to get to quick fixes because that pipeline is the lifeblood of my team. Here are some other possible KPIs. So let's see. Things we might want to measure, right? Amount of branches, test code coverage, horrible, right? Amount of tests, horrible. Do we agree on that? That's just like testing amount of lines. But they're not bad things to look at. They're just bad things to have people accountable on. Pipeline runtime, that might be interesting, right? What, the pipeline takes 5 hours to finish? Okay, how long does it take this week? How long does it take next week? Someone might actually do something about running the pipeline in parallel and all that stuff. Visibility. What if I measure visibility of the pipeline? Can anyone see the pipeline without logging in? What if I measure visibility? Visibility is a great factor in social ability. Hey, I feel empowered to do something because we're all looking at the same screen, looking at the same information, and talking about the same thing. It's not that every one of us got an email and nobody cares about it. We got an email, maybe I'll do something about it, maybe someone else will. No. There's peer pressure now. That stuff is read. It's read when I come back from lunch. It's read when I go to the bathroom. Oh, is anyone doing something about that red bill, by the way? That's what you want to hear in a team. Maybe even better, maybe the team will develop a support shifts. Every day, one person is responsible for the red bill. That person understands why the build is failing and moves it on to other people as requested, but everyone else can continue working, so nobody feels like it's never their job. Etc. Time between pull request and reply. That's when you want people to, work with each other more. How many feature flags do we have? How much stuck time do we have? These are metrics that change behavior towards continuous integration. Okay. So, just to summarize, we actually want to be able to change large organizations, we have to understand influence forces. Every time we look at something, we have to understand it, not just at the most basic level of someone wanting to do something or someone able to do something. We also want to look at the people around that person. We also want to join the meetings that person joins to see what are the things that he's being accountable for. We want to look at how that person is being measured. We want to map the entire flow across the organization so we can see where is that person in the entire flow of things. What if we don't actually optimize this, but we look at that stuff? What if we look at those things and we take them on numbers? We can then make huge changes, especially at the most high level where we can shift resources into doing the right things instead of doing the easiest things, which is what a lot of organizations try to do. If you have any more questions or if you want to learn more, go to enterprisedevops.org or 5wise.com, which is all about the influence forces and the leadership stuff. Catch me on Twitter. And thank you very much, everybody. It's been a pleasure.